This is part 2 to test 1 review, chapters 1 through 4. I went ahead and made my stem and leaf plot. Would 93 be unusual, and why? No, because it is greater than the 0.05%, so 93 would not be unusual. I went ahead and made my relative frequency chart. These are my classes. There was 1 in this class, 1 in this class, 2, 4, 6, 7, 4, 2. The relative frequency is 1 divided by the total, so there were 27 pieces of data. So here are my relative frequencies. I then sketched a histogram by classes and by the frequencies. And is the data normal? No. Seems to be skewed a little to the left. Your child comes home sad because she scored in the 75th percentile. She is so bummed because she thinks she has made a D. How would you respond to be statistically correct? Well, you would say that she did better than 75% of those that took the test. It does not tell the grade. Let's say that 74% of the people made a 90 on the test. Then she made better than a 90 on, her grade would be better than a 90. It really depends on what the people in front of her scored to actually tell what her score is. And we cannot find that from the data that is given to us. So this is a weighted mean problem. This is a weighted mean problem. And we have 10 gallons of the 70-degree mixture. And we have I've got that. We've got a 70-degree water and we've got a 110-degree water. And we have 10 gallons of this one and 15 gallons of this one. So what would our weighted mean be? So we would take 70 times 10 plus 110 times 15 divided by 10 plus 15. I got 156.7. And if we did it in one variable stats, we would put it in list 1 and list 2. Stat calc 1, but we have to remember to put in L1 and L2, and that mean is 94. Well, obviously it can't be 156 because that's 110 degrees. Let me do this calculation again. 70 times 10 plus 110 times 15 divided by 25, which is 94. I divided by 15, I believe. So the average temperature would be 94 degrees. Given each pairing, determine who did better and explain your answer with percentages. Well, a quartile 2 means that you've done better than 50%. Decile 2 means 20%. So if you did better than 50%, then you did better than half. If you did better than 20%, then you did little less than half. So this says that you did better than 36%. And this says 4 out of 11. Ooh, 36.3%. That's a little too close, but technically this, I guess, would be better because you did better than more people than this one. That's a little too close for comfort. It would probably be more like a probability of, let's say, 47% and 7 out of 11. Let's see, 7 divided by 11 is 64%. So this one would be better in this case. On both cases, this side would be better. On a recent exam, the scores were normal with an 18 mean and a standard deviation of 2, and they were in 60 trials. Label the empirical rule. So this was the mean. Standard deviation means to add 2, add 2, add 2, subtract 2, subtract 2, subtract 2. This is 34%. This is 13.5, 2.35, and 0.15. And what range would contain the middle 68%? So that would be from 16 to 20. 68%. How many grades would be in usual range? So that would be from here to here because it's 2 standard deviations. So that would be 95% of the grades, which there were 60 grades. So 0.95 times 60, that would be 57 grades. Show formula used to calculate the z-score. X minus the mean divided by the standard deviation. Calculate a z-score for 25. So that would be 25 minus the mean, which is 18, divided by the standard deviation, which is 2, which is 3.5. Is this usual or unusual? This is unusual because it is more than 2 standard deviations from the mean.